Algebra, we are starting off the home stretch of the year, our third book, with CO44, finding the greatest common factor of a set of monomials. Now, we'll get into this a little more in CO45, but the term nomial just means an expression, okay, or term, right? Who knows what the prefix mono means? Mono.
The disease my brother got.
Yes, it is a disease. It's called mononucleosis because that prefix mono means what? One. Okay? One. So we're talking about one-termed expressions, and we're looking to find the greatest common factor of them. Okay? Now, going back to your greatest common factor days, what is the greatest common factor? How would you define it? Boys. Evan, Blake, if you'd rather go in the hallway and just sit, then you can talk out there.
I didn't say anything.
Would you like to go out in the hallway and sit, or do you want to stay in class?
No.
No, to which one? Huh? No, to which one? Out in the hallway and sit, or stay in the class?
I'd stay here.
Okay. How would you define greatest common factor?
Greatest.
The greatest common factor. Okay. So what's a factor?
A number all of them go into.
All right. So a number that goes into another one. Okay. The greatest common factor in this case is we're looking for the largest term that goes into the set of terms. Okay. When we talk about greatest common factor in pre-algebra, it was the largest number that goes into the set of numbers, right? We only found the greatest common factor of numbers. Now we're finding the greatest common factor of terms. So it's the largest term that goes into the set of terms. Okay, same idea, but we're replacing number with terms because now we got variables and things like that, right? So looking at the three terms here, 18x cubed, 27x squared, and 15x, I'm going to write these out in expanded form just to give us an idea, just remind ourselves what a power means. 18x cubed is 18 times x times x times x, right? 27x squared is 27 times x, and then 15x is just 15x, okay? And we're looking for the greatest term that goes into all of them. And we start with just the numbers. Start with the coefficient 18, 27, and 15. What is the largest number, the greatest common factor that they all have? 3. Okay? And how you know that is you might think of, well, the factors of 18, right? 6 goes into 18, doesn't go into 27 or 15. 9 goes into 18, 9 goes into 27, but not 15, right? 3 is the largest number that goes into 18, 27, and 15. Now we get to what makes this terms rather than just numbers here, and the greatest number of x's. Our first term, 18x cubed, has 3 x's, right? X times x times x. Our second term, 27x squared, has 2 of them, okay? Our third one only has the 1. So what's the greatest number of x's that all terms have? Not just the greatest number, but that they all have. They all have 1, right? 1x, 1x, and 1x, okay? They all just have 1. Some have more, but they all have 1. So the greatest common factor of putting those things together, 18x cubed, 27x squared, and 15x, is 3x. You find the coefficients first, the GCF of the numbers first, then the variables, and put them together. Questions on that? Okay, let's look at the next one. Our 3 terms are 32x to the 7th, 40x to the 5th y, and 16x to the 4th y squared. Okay, so again, starting with those numbers, starting with those coefficients, what's the GCF of 32, 40, and 16?
I got that. 4.
It is larger than 4.
8.
8.
That's the same thing.
But bigger. Okay? 8 is the GCF of 32, 40, and 16. Now, what are some methods that we've talked about in the past on how to find greatest common factor? Some of you might still look at them and run through the factors in your head. What if you're not there yet? What else could you do? You could list the factors of each of them, right? 32, you've got 1 and 32. You've got 2 and 16. You've got 4 and 8. You know, write out the factors of 40, write out the factors of 16, and say, what's the largest one? You'll find that it's 8. What else could you do? We also learned of a table method. If you recall this one, you would make kind of a chart. And we've got 3 numbers. So we've got 32, 40, and 16. Anyone remember this?
Yes.
If not, jot this down so you can refer to this. If you have trouble finding the GCF of the numbers, which in this case is kind of the hardest part here, this is one way to do it. What's a number? And let's not pick 8. But what's a number that goes into 32, 40, and 16? 4 does. Okay. 2 does also. Let's put the 4 there. And then what you do is you divide each number by that 4. Okay? If you had chosen 2, you divide each number by the 2. But whatever number that you see goes into all 3 of them, you divide each number by that, and now we get 8, 10, and 4. Okay? And then again, you ask yourself here, what's a number that goes into 8, 10, and 4 evenly? 2. In this case, there's only one option, and that's 2. Okay? So you, again, divide by the number that you took out, in this case, 2. 8 divided by 2 is 4. 10 divided by 2 is 5. 4 divided by 2 is 2. Are there any other numbers that go into 4, 5, and 2? No. So you know that you'd be done. You've got as far as you can, taking out numbers from all 3 of them. And then your GCF just comes from the product of the numbers that you have on the side there. Okay? So you can either list the factors, or you can kind of use this table method here. We talked about both of them last year. What was it? PO4, PO5, something like that. So if you kept your pre-algebra binder, right? Okay, if you did, you should be able to find those methods in there. But either way, 8. Fantastic. What is the greatest number of x's that all terms have? Now we've looked at our coefficients. Bella, Jeffrey, now we're looking at our x terms. What's the greatest number of x's that all terms have? Abby?
4.
They all have at least 4. Some have more, right? This has got 7, that's got 5, but they all have at least 4. Okay? So we're pulling out an x to the 4th. That looks too much like x times 4. X to the 4th. And then what's the greatest number of y's that all terms have? 0, right? The first term doesn't have a y. Okay? So it's not going to be part of our greatest common factor answer because not all of them have that y variable. So then the GCF of those 3 terms together, we take our coefficient GCF, that 8, we take the greatest number of x's that all terms have. They don't all have a y, so we can't include that, and there's our final answer, 8x to the 4th. The next one. What is the GCF of the coefficients? 42, 14, and 70. What goes into all 3 of those numbers, even in the greatest number that does?
Oh, 7. Sure, I understand.
Let's do this chart over here because this is fun. We got 42. Oops, not there. We got 42. Uh, 14 and 70. What number can we pull out of 42, 14, and 70?
7.
7 does. Okay? So we put our 7 here. We divide everything by 7. In our next row, 42 divided by 7 is 6. 14 divided by 7 is 2. and 70 divided by 7 is 10. Now, when I asked you initially, what's the GCF of 42, 14, and 70, I heard a few people saying 7. But we see this here, and are we done? No, because what goes into 6, 2, and 10? 2 does.
14.
And so you divide each by 2, and you see that in actuality, because there's no number that goes into 3, 1, and 5, Jack, our GCF is 7 times 2, or 14. Okay? So on the test, Jack, most people, if they don't pass this objective, it's because they get that coefficient wrong, because it's actually more difficult to find the GCF of the numbers than it is for the variables. Because for the variables, you just kind of have to look at it. You know, what's the greatest number of x's that all terms have here? The first one's got x cubed. The second one, x to the 5th. The third one, x to the 6th. What's the greatest number they all have? They all have 3. Right? Some have more, but they all have at least 3. Blake, you have a question? Okay. And then what's the greatest number of y's that each term has? Again, 0, because that third term doesn't have a y. Okay? So our GCF of these 3 terms, they all contain 14 as a factor of the coefficients, and they all have at least 3 x's. Okay? Anyone kind of see not so much a shortcut, but an alternate way to look at getting these variables here? The way that I phrased the question is, what's the greatest number of x's that all terms have? But really, what are you looking for? The smallest power, right? The smallest exponent will represent the greatest number they all have. Back with the second one here. This one's got 7, that's got 5, that's got 4. The greatest they all have is 4. You can identify that by looking at what's the smallest exponent, right, with those x terms there. So you can kind of flip it and look at it a different way to answer the same question. Homework for tomorrow is to finish out CO44. I told you we could do it. I believed in us, and we did it. Looking at that GCF, those coefficients, and then those x's as well. Well done, John. Well done. Congratulations, John. All right, folks, that's my math. Like, subscribe, all the things.